So we've seen that a histogram is a way to take a quantitative variable and categorize it. In this video, I'm going to show you how to create those categories. So here are the ages that we dealt with in our last video. Bunch of people in a room, we just take all their ages and we've got this data table. Now we want to create categories, or more commonly called bins, when we talk about histograms. So we're going to create bins, but we want these bins to have equal sizes. Why? Because if you have one bin that covers just a couple of different ages, maybe ages 4 and 5, and then another bin that covers ages 6 through 16, that's going to have a disproportionate display of the data. So we want these bins to cover even spaces. For example, 3 to 4, 5 to 6, 7 to 8, 9 to 10. We want the age gaps to be the same in each bin. The way we're going to do that is these 5 steps. We're going to first of all determine the range of our data. Then we're going to determine the number of bins that our histogram needs. And then using both of those pieces of information, we're going to actually create the bins. Then the final step in creating the categories is to count your data. Okay, those 4 steps are needed for creating the categories. The very last step is take those categories, create a bar graph with it, make yourself a histogram. Let me go through those first 4 steps here in this video with you. First of all, determine the range. The range is just the width of the number range that you are dealing with. So in this case, we just take the maximum value, subtract it from the minimum value. What is that difference? So if we look at our data, the maximum age is 27, the minimum age is 3. What's 27 minus 3? It is 24. Okay, so our range is 24. Take that information, put it to the side just for a second. Now, we need to determine the number of bins. We're going to follow what's called a power of twos rule. Now, let me just clarify here. There's no really hard answer to determining the number of bins. You can have 4 bins, you can have 20 bins. It really doesn't matter. It's just that sometimes 4 bins is more effective than showing 20 bins. Sometimes 20 is more effective than 4. So this is kind of a good rule to follow to give you a general idea of about how many bins you should be dealing with. Okay, here's the power of 2's rule. First of all, you take your sample size. You count how many data points you have. In this case, our sample size, which we're going to call n, is 42. There are 42 people in the room, and I have their ages in this table. Okay, now I'm going to take this sample size and I'm going to compare it to all the different powers of 2. So by this I mean, what's 2 to the power of 1? What's 2 to the power of 2? 2 to the power of 3, 2 to the power of 4, and so on. 2 to the power of 1 is just 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. 16 is 2 to the power of 4. 2 to the power of 5 is 32. 2 to the power of 6 is 64. 2 to the power of 7 is 128. We could keep going, but at this point, you're rarely going to have more than 128. No, I shouldn't say that. You will have more than 7 bins, but I'm getting ahead of myself here. I'll just go up to this point. You can keep going if you need to. Okay. Now, whatever that power is, that would be the number of bins you have. So 2 to the power of 1 is 2. If that's going to be our choice, then we're going to have 1 bin. 2 to the power of 4 is 16. If we have 16 data points, we're going to have 4 bins. Okay, that's the key. Take your sample size and compare it to all these powers of 2. So in the powers of 2, we have 2, 4, 8, 16, 32, 64, and so on. Our sample size is 42. That sits right in between 32 and 64. Okay, with 32, that was 2 to the power of 5, so we have 5 bins. 64 is 2 to the power of 6, we could have 6 bins. Either of those would be good. So you can have 5 or 6 bins in your histogram. This is the rule we're going to follow here in this class when we make histograms. But remember, it is kind of arbitrary out there in the real world. Roughly arbitrary. This is a very good rule to follow in that. Okay, now, if you were confused by everything that I explained, I get it. It's kind of weird. Let me make this even simpler for you, okay? I'm just going to get rid of the x and the 2 to the power of x, and we're just going to say we're going to use doubles. Start with 2, okay? We start with 2. That would be 1 bin. Double it. That would give you 2 bins. Double it again. That would give you 3 bins. Double it again, that would give you 4 bins. Double it again, that would give you 5 bins. However many times you have to double the number will be how many bins you have. All right? So let's do this as an example here. We have 42 data points. How many times do I have to double in order to, how many times do I have to do my doubles to reach the number 42? Okay? So we start off, we do 1 double, that gets us to 2. So that's 1 bin. Double again, 4, that would be 2 bins. Double again, that's 8, that's 3 bins. Double again, 16 would be 4 bins. Double again, 32 would be 5 bins. Double again would be 64, that's 6 bins. We've passed the number 42. So 42 is somewhere between 5 bins and 6 bins. Okay? Just count the number of doubles. How many times, you start with 1, how many times do you have to double to pass up your sample size? That's how many bins you'll have in your histogram. All right, so like we said, we had to double. We started with 1, we had to double it 5 times to get to 32, 6 times to get to 64. 42 is right in between those two, so we do 5 or 6 bins. I'm just going to choose 5. I think 5 is a good number, so you can choose 6. There's nothing that says you can't. We're going to stick with 5 bins. Perfect. So we determined the range was 24. That was our first step. We determined the number of bins. That's 5 bins. Now we're going to actually create the bins. We need 2 things. We need the bin size and we need the starting points. All right. The bin size, you're going to take your range, which is 24. We've got 24 different ages. And we're going to divide them into 5 different bins. We're just taking our range and dividing it into 5 pieces. That's all we're doing. 24 divided by 5 is 4.8. You can't have 4.8 bins because there's no such thing as 0.8 bins. So we're going to round this up to 5. So our bin size is 5. All right. So we're going to create 5 bins. Let's create ourselves a table. This table has the start of every bin, the end of every bin, and the count. We'll worry about the count later, but we're working right now on the starting point of each bin. Well, the first bin, you start with your minimum value of 3. And since the bin size is 5, we just determined that with our last equation, then the next bin starts 5 units later. So our minimum is 3, bin size is 5, so add 5 to it. The next bin starts at 8. Then your bin size is 5, add another 5, that puts you at 13. That's where the next bin starts. Add another 5, next bin starts at 18. Add another 5, your next bin starts at 23. And I'll explain the plus in just a second. All right? So those are the starting points. So where are the ending points? Well, your first bin starts at 3. Your second bin starts at 8. So the first bin has to end at 7. Okay? So each bin ends one number before the next bin starts. 3 to 7, 8 to 12, 13 to 17, 18 to 22. And then this last bin, we don't really have an ending point for that bin. We just leave that as an open bin. We just say anything over 23. That's what the plus means, 23 and above. All right. And there are our bins. Now that our bins are set up, we can do a count. Oh, I need to mention this. What if we have decimals as our numbers? What if we're dealing with, I don't know, say money, and we need to account for cents? All right. Then we can do decimals as well, but this time, first bin starts at 3, second bin starts at 8. If we need to do a decimal, then maybe the first bin will end at 7.9. Or if we need to do 2 decimal places, as in the case of money, maybe the first bin ends at 7.99. And then the next bin would start right at 8. Perfect. We're going to stick with the first one we had with this example, just because we're dealing with whole numbers. We don't need to go with the decimals. But I'm just making you aware you can do this with decimals. Now that our bins are set, we are ready to count the data. So we just go look at our data and we count how many data points are in the range from 3 to 7. Well, I've highlighted that in this graph or in the table. We have 4. How many data points are between 8 and 12? We have 9, and so on. You just count up how many are in each category. You've got this table. You have now officially categorized your quantitative data. You've taken your numbers, your quantitative data, and you've sorted it into groups. The group 3 to 7, the group 8 to 12, group 13 to 17, 18 to 22, and then 23 and above. Now, at this point, you are ready to create your histogram.